Okay, so we have not yet covered how to take the inverse trig functions of inverse cosecant, inverse secant, and inverse cotangent. And here are the domain and ranges here in green of each of those. And I want you to notice a couple of things here is that the similarity between the inverse sine and inverse cosine ranges. Inverse sine range is negative pi over 2 to pi over 2 to positive pi over 2. And that's virtually identical to the inverse cosecant range, which is also negative pi over 2 to pi over 2, except for the value of at 0. At 0 radians, that function is undefined. But it's very similar. And also look down here at inverse cosine and inverse secant. They are also have very similar ranges here. The range for inverse cosine is 0 to pi, and the range for inverse secant is 0 to pi, but except at pi over 2, it's undefined. So actually, the reason, because these ranges are very similar, the way I'm going to show you how to do problems that involve those inverse trig functions, if we can call them those reciprocal inverse functions, the ones that, since cosecant is the inverse of sine and secant is the inverse of cosine and so on, when we do a problem that involves inverse cosecant or inverse secant, we're going to actually use the inverse sine and inverse cosine to get those answers. We will do it also with inverse tangent, but there's a little caveat, and I'll show you that when we get to a problem, because you'll notice that these ranges are not alike at all. In negative pi over 2 to pi over 2 is the range of the inverse tangent. Those are the angles you get out of the inverse tangent. And the inverse cotangent, though, is gives you angles back out of the interval 0 to pi. And so it's more like, more similar to the range of the inverse cosine than it is its reciprocal, the inverse tangent. But I'll show you how to tackle that when we get to that. So right now, we're going to do some problems involving those, and then I'll explain how to work these. So get to the right place in my notes. All right, we're going to take a look here at number 42 first, and it says find the exact value of each expression. Find the inverse cosecant of negative 2. Well, so like I told you, what we're going to actually do is to find the inverse cosecant of negative 2, we're going to actually change this problem into something that is equivalent by switching the secant to inverse secant to its reciprocal, which would be the inverse cosine. And because we've changed to that reciprocal inverse function, we're actually going to reciprocate the number that we're taking in the inverse secant of. Think of this as negative 2 over 1. And we're going to reciprocate that, and this would be negative 1/2. Now, the reason we can do this is, if you think about it, again, what is the inverse secant of negative 2 asking us? It's basically saying, hey, we have a secant value of negative 2. What's the angle that has that secant value? And of course, it's going to be a secant, it has to be an angle that's within 0 to pi, not including pi over 2. But that's what basically it's the ratio. Remember, the secant is the ratio of two sides of a right triangle. And of course, the cosine is just the reciprocal of that. And so that it allows us to do that. If you think about, let's see here, this is let's just keep going, and I'll explain that a little bit more. Let's work with this inverse cosine, and then I'll go back to why this works again. The inverse cosine of negative 1/2, that gives us angles back in the first and the second quadrant. And since cosine is negative, it has to be in the second quadrant. So if you think about it, we look over here and draw an angle in the second quadrant that lies in the second quadrant, And we'll do a reference triangle here. And the cosine is negative 1/2. So this would be negative 1. And this would be 2. Which would then, of course, this is our reference angle right here that we're going to use. So that represents the cosine of that, right? Well, remember the cosine is just the it's going to be the adjacent over the hypotenuse. Well, what is the secant? The secant is just the reciprocal of that, right? Because remember, this is a secant value. This is a cosine value. Well, what is this? Secant is just, well, it's the hypotenuse over the adjacent. Hypotenuse over the adjacent. That's what this is. So the reason we can just switch that inverse secant function into something that's equivalent using its reciprocal, the inverse cosine, is because, again, we're just simply saying, hey, we already know that reciprocal relationship between secant and cosecant, or excuse me, secant and cosine, that those ratios of the sides of the triangles are just reciprocals. So that's why we can do that. So now we're just basically looking for, what's an angle there in that second quadrant that has a cosine value of negative 1/2. Look at our unit circle, and we're looking for a cosine, which would be an x-coordinate of negative 1/2. So that looks right up here at 2 pi over 3, or 120. 2 pi over 3, or 120. So that's what we would put down here. And that's our answer, 2 pi over 3, or if we're giving this in degrees, it's 120 degrees. Let's take a look at another one here. How about number 39? Number 39 says, what's the inverse cosecant of negative 1? Again, that's number 39. Inverse cosecant of negative 1. All right, well, that's the same thing as saying, well, what's the reciprocal of cosecant is the sine. So that's the same thing as saying the inverse sine is also negative 1, because what's the reciprocal of negative 1 is negative 1. So if we need to find an angle between negative pi over 2 and positive pi over 2, where the angle would be, if it's in the fourth quadrant, we're going to give it as a negative angle. If it's in the first quadrant, we'll give it a positive angle, because that's the range of the inverse sine. So we're looking for a sine value of negative 1, and it's down here on our unit circle. Remember, all of our angles are positive that we have on our unit circle. And so it's down here at 3 pi over 2, or 270. But again, that's not our answer, because the inverse sine, when it gives you an angle that's down between 0 and negative pi over 2, we have to give the negative angle measurement for that. So that would be a negative pi over 2. And so that's what we're going to answer it as, negative pi over 2. So that's the answer for that. Let me highlight the answers for these. Or you could also say negative 90. And you can confirm all this. We'll get some calculator problems in a minute, and I'll show you how to do those. But you can confirm your answers using the calculator. Let's take a look at number 41. Number 41 here, the inverse secant of 2 radical 3 over 3. That's 41. Inverse secant. I have a hard time writing this. Inverse secant of 2 radical 3 over 3. Well, let's change that into an inverse cosine. That would be the reciprocal inverse cosine of, then we have to reciprocate that, so it would be 3 over 2 radical 3. Now we're going to have to move down to do the rest of that. And I want to separate this off from the previous problem so it doesn't get mixed up. Okay, so we'll move down here. And I can't leave that radical down there. So let's say this is equal to the inverse cosine of So it'd be 3 over 2 radical 3, right? Let's rationalize that. Multiply by radical 3 over radical 3. Just working with that inside, try to simplify it. So it would be the inverse cosine of, well, it's 3 radical 3 over, well, radical 3 times radical 3 is 3 on the bottom there in the denominator, times 2. So 2 times 3 is 6. And then that will simplify. Inverse cosine of radical 3 over 2. So my answer to my initial question, what is the inverse secant of 2 radical 3 over 3, is going to be the same thing as what's the answer to what is the answer to the inverse cosine of radical 3 over 2. So we need to find an angle whose cosine is radical 3 over 2. It has to be in the first or the second quadrant, since inverse cosine gives us angles back in the first or the second quadrant. Since the cosine is positive, it's going to be in the first quadrant. So we're looking for an angle in the first quadrant whose cosine is radical 3 over 2. So we're looking for a cosine of radical 3 over 2. It's right here at 30 degrees or pi over 6. 30 degrees or pi over 6. So that's our answer. This is 30 degrees or pi over 6. All right, let's do one. Well, we're actually going to do two more. Number 37 here. Take a look at that one. And that is, what's the inverse cotangent of radical 3? Okay. And now I'm going to go ahead and use the inverse tangent here. In the next problem, we'll see why we have to make an adjustment sometimes if we're going to do an inverse cotangent problem and convert it to an inverse tangent problem. But if I reciprocate this, would this be 1 over radical 3? And if you rationalize that, that is the inverse tangent of 1 over radical 3 over 3. So we would be looking for an angle whose tangent value is radical 3 over 3, and the inverse tangent gives us angles back that are in the first or the fourth quadrant. Since the tangent's positive here, it's going to be in the first quadrant. So we'll take a look. And basically what you're going to have to do is, if you don't have these memorized, the tangent values, that is you're going to have to take the sine, right, which is the y-coordinate, and divide it by the x-coordinate. And you'd find out that pi over 6, or 30 degrees, will give you that. Because if you take this y value, which is the sine, and divide it by radical 3 over 2, you will get that answer. All right, so it's 30 degrees or pi over 6. Okay. All right, let me highlight that. All right, one more problem in here we're going to do is number 43. And this will illustrate why we have to be careful when we do the inverse cotangent. And when we switch it to inverse tangent. So this problem is, what is the inverse cotangent of negative radical 3 over 3? I'm going to cut to the chase here. Of course, I'll change it over to inverse tangent. And then that would be a negative 3 over radical 3. If you rationalize that, and this is where I'm just going to not show every little step here, but if you rationalize that, okay, you will end up with negative radical 3. Okay, so basically we are looking for an angle whose tangent value is negative radical 3. And so now remember, inverse tangent is going to give us an angle back that is in the first or the fourth quadrant. So let me just kind of illustrate this here. So there's our, inverse tan would give us an angle back here, or down here. And the inverse cotangent, which this original problem was in, would give us an angle back in either the first or the second quadrant. And you can see then, if our angle happens to be here in the first quadrant, those ranges of those inverse trig functions, they overlap. So we really don't have an issue, actually, if, like in number 37, the cotangent value is positive. So we know that that angle, if we have to choose between the first and the second quadrant for the inverse cotangent, well, then the angle's in the first quadrant because that's where the cotangent's positive. However, if we have a cotangent value like in this number 43 that we're working on now that is a negative value, and with the inverse cotangent you have to choose between the first or the second quadrant, that's going to give you angles back in those two quadrants, then since the cotangent value is negative, it's going to be in the second quadrant. Now, so hang with me here. So that this particular angle should be in the second quadrant is what the inverse cotangent is going to give us back. However, when we switch it to the inverse tangent, what's going to happen is, since the tangent value is also negative, it's going to give you an angle back in the fourth quadrant. Okay? And so the problem is then what we need to do is say, well, what angle would that then be up here that has the same value as the tangent down here, right? So all you have to do is once you get this angle down here in the fourth quadrant, then to find the other angle that has the same tangent value that's directly across from it up in that second quadrant is simply use that little reference angle there, and or you can just simply add 180 because this is 180 degrees difference. 180 degrees or pi radians. So here's the bottom line. This inverse tangent negative radical 3, that will give you an angle down here in the fourth quadrant, and it's going to be negative 60 degrees, which would be right here at 300. If you take this sine divided by the cosine, you'll get negative radical 3. And so I know it's listed here as 300 degrees or 5 pi over 3. But remember, inverse tangent is going to give us a negative angle down there. And that measurement of that negative angle that has the same terminal side as 300 is going to be negative 60 or negative pi over 6. So, or pi over 3, I mean, negative 60. So here, our theta that we get from this inverse tangent is equal to negative 60 degrees. But if we want to find out what the inverse cotangent would give us, which is what we need to do, we're going to have to add 180 degrees to that. And that would give us a 120 degree angle. So it's 120, or if you look on your unit circle, that's 2 pi over 3. So bottom line here, anytime you're taking the inverse cotangent of some number where the cotangent value is negative, if you're going to use the method that you change it over to an inverse tangent first, then you're going to have to always add 180 degrees or pi to that. Your book does a different method. They actually show you how to, they just have you draw up a reference triangle and then convert it to the cosine, and then you do inverse cosine, because the inverse cosine and the inverse cotangent have ranges that match up better. But this works. So that's the only little caveat. With the inverse cotangent as a positive number, you have no worries. It's not a problem. Okay, let's talk about one more thing here in section 8.2, and that is how to do some of these calculator problems. Okay, so we'll take a look at how about number 54 here. Where it says the inverse secant is negative 4/3. Okay, now what we're going to do is, now you don't have an inverse secant key on your calculator, so we can't use that. We have to choose that method that I was just showing you, where you're going to change that to an inverse cosine, this reciprocal, and then reciprocate the number in there. Because if something has a secant value of -4/3, it's going to have a cosine value of -3/4. So now then we can go ahead in our calculator. I'm going to put mine in degrees. Let's see what we're in. Looks like I'm in radians here now. Let me get out of this here. So I guess, okay, I'll stick with radians right now. And then I'll also do it in degrees. So we had, what was it? The inverse cosine of -3/4. So second inverse cosine, -3 divided by 4. Let me go back here. That's the radian measurement. You can see I'm in radians. If I want to convert that to degrees, I would just multiply it by 180 divided by pi. And there's my answer in degrees. So you know, the calculator problems, you just have to remember that you're going to have to use the reciprocal inverses to get these. Right, so if we're going to round this to 2 decimal places like they set up here, then in radians, this would be 2.42 radians. And then down here, this would be 138.59 degrees. Okay. Okay, so now let's do that cotangent one there, because that'll also explore that little adjustment we have to make. Because look, this is the inverse cotangent of -3/2. And so we just realized that before, that whenever we do the inverse cotangent of a negative cotangent value, we're going to have to add on pi or 180 to get the correct answer. And that means we'll have to do the same in the calculator. So if we do inverse cotangent of -3/2, that equals the inverse tangent of -2/3 plus 180 degrees. Remember, don't forget to add that because of our negative cotangent value. So let's see here. We've got, clear that. So we got inverse tangent of -2 divided by 3. I'm still in radian mode. Okay, so we're going to multiply by 180 over pi to get also the degree answer in case we needed that. And so it's a -33.69. Copy that for the notes. All right. Oh, I can't believe I did that. Forgot to add the 180. So let me go back. Go backwards here. And then add onto that pi radians, right? Because that's actually, I'm in radian mode. So there's my radian answer for the actual correct answer. And then I can convert that to degrees. There we go. That's better. All right. Get rid of that. So what we'll do here is, you know, these are not what I'm looking for here. It's these right here. So this is our radian answer. It's 2.55 radians. or it's 146.31 degrees if we round it to 2 decimals. So, okay, so that finishes out our section 8.2.